Okay, so me and Sachin are doing our section on vectors and velocity and acceleration. So we'll start off with the general form. So if r of t is the position function, or it's also called the vector valued function, then velocity is just the derivative of that. So v of t equals r prime of t. Then acceleration is a of t or r double prime of t. So if we have a form of a vector such that r of t equals x of t I plus y of t j plus z of t k, that is the position or vector valued function. And so to take the derivative of that, we'll just go x prime of t, and then y prime of t, and z prime of t for all of those, and that's the velocity. And then to find the acceleration, we just take the second derivative, so that's x double prime of t, y double prime of t, and z double prime of t. And then you can also use the velocity vector to find the speed, so you just take the magnitude, which is the square root of the different components of the velocity vector squared, and that will give you the speed. And so, for example, if we had a function or a vector such as this, which can be written also as this, to find the velocity vector, we just take the derivative of that. So t cubed would become t3 squared, sine t would become cosine t, and e to the t would stay as e to the t, and that would give you the velocity vector. And then for acceleration, we would just take the derivative of our velocity vector, which is the second derivative of the position function. So 3t squared would become 6t, cosine t would become negative sine t, and e to the t would stay e to the t, and that's the acceleration vector.